Okay, so let's talk about what we call the odd even identities. The odd even identities, these six down here, which look a little weird, but we're going to talk about them. They do come up a little bit. They do come up a little bit, but they only come up basically just to decide if an answer is positive or negative. So here's the way this goes. These guys right here, sine, cosecant, tangent, cotangent, are called the odd identities. Because if I put a negative on that theta right there, what I can do is just bring the negative out front and make it a positive theta. So sine of negative theta is really negative sine theta. So that works for all four of these. The ones we call the even identities are, if I have cosecant negative theta, that makes cosine theta. We're just, so cosine and secant, we're just dropping the negative. So you're thinking, well, that seems kind of weird. Well, if you think about it, let's do an example. Like if I said, what is sine of negative pi over 6? Is that equal to sine of positive negative? See, are these two things equal? Like if I say negative pi over 6 here, and then just bring the negative out front, well, let's see. Well, let me see. Sine of pi over 6 is 1/2. But wait a second, negative pi over 6 is in the fourth quadrant and sine is negative. Let me see. Sine of pi over 6 is 1/2. But wait a second, it's got that negative out front. So, so I got negative 1/2 equals negative 1/2. This would work. We could do an example for all of these. Like if I said, oh no, what's tangent or cotangent of pi over 4? You could say, well, I'll bet that's going to work. Let me see. Tangent of pi over 4 is 1. But negative pi over 4 is fourth quadrant, and tan's negative. Tangent of pi over 4 is 1, but it's got a negative out front. So all those check. So it works. So these work. And I'll show you where it's going to come up in a second. The even functions are things like, well, if I said, all right, so I've got cosine negative pi over 3. That should be equal to cosine of positive pi over 3. Well, that seems weird. Well, let me see. Cosine of pi over 3 is just 1/2. So cosine negative pi over 3. So, okay, so it's pi over 3, so it's 1/2. And let me see, negative pi over 3 is in the fourth quadrant. Oh, and cosine's positive in the fourth quadrant. So it does check. So it would work that way. Okay, I can't guarantee. The way I always remember this is this. If I have an even function, like f of x is equal to x squared, because back when you were in algebra 2, you probably learned that this is called an even function if all the exponents are even. So if I said, okay, what's f of 2? Well, f of 2 is equal to 4. Well, what's f of negative 2? Well, f of negative 2 is also equal to 4. So it didn't matter. So f of 2 was equal to f of negative 2, just like we're saying here. F cosine of 2, or cosine's pi over 3, is equal to cosine negative pi over 3. So the way I always remember this is the even functions are like x squared. You would get the same answer if you change the sign. And I mean the plus or minus. If you change the plus or minus, you would get the same answer. Whereas if you had something like x cubed and said, okay, what's f of 2? Well, that would be 8. F of negative 2 would be negative 8. So I'm about to sneeze. So what are we saying here? Are f of 2 equal to f of negative 2? No, they're not equal. I have to put a negative in front of one of them. So like if I'm saying f of negative 2 is negative 8, f of 2 is positive 8. Well, to make them equal, I need to put a negative in front of that. So I put a negative in front of that. So that goes back to giving me this right here. See, the theta is negative. When I change the theta to positive, I had to put a negative out front. So the theta is negative. When I change the theta to positive, I put a negative out front. So, oh, it's an odd power. So to me, that's kind of what it always meant to me, that's why they call them even and odd, but I can't guarantee that. I don't know. That's just the way I always remember it. Okay, so here's where this is going to come up in terms of problems. See, a few minutes ago, we said things like, oh, well, if I've got tangent negative theta times cosine negative theta. See, we'd say to ourselves, well, tangent is odd, so that means that negative is going to come out front. Cosine is even, so we can basically just drop that negative. And now it's just tangent times cosine, which we did in the previous introductory video. So, oh yeah, that just makes sine. Oh no, but it's got the negative out front because we threw in those negatives to see if you were paying attention. Something like, I don't know, if we had cotan. Oh, here's a good situation. Here's a good situation that's going to come up a lot. If you've got something like sine theta times secant negative theta. Sine times secant negative theta. Well, first of all, the negative, since it's secant is even, you just drop the theta. Secant is even. Secant is even. I'm sorry, so you just drop the negative. Secant is even, so you just drop the negative. So you'd say, well, this is really just sine theta times secant theta because I don't need the negative here. And then, like I said on the previous video, how do I clean this up? Well, let me see. Secant is 1 over cosine, or as I like shortcut, I like to say secant on the top is the same as cosine on the bottom. Secant on the top is the same as cosine on the bottom. So either way you look at it, you get sine over cosine, which is tangent. So this is one of those things that you're going to see a lot of, like sine times secant ends up being tangent. Okay. I don't know. Where do you want to go from here? Something like cosecant negative theta times cosine theta, like that. Well, cosecant's odd, so the negative can come out front. And then you'd say, oh, and I'm going to do the shortcut here. How about this? Cosecant's the reciprocal of sine. So cosecant on the top is the same as sine on the bottom. Oh, cosine over sine is cotan. So I'd end up with negative cotan. So you may see a few of these problems where we throw the negatives in like this, the odd even functions, but that's all it comes down to is when you take the negatives out front, sometimes the negatives might cancel, sometimes they won't. All right. So that takes care of the fundamental identities.